So I left off the last episode in a somewhat hopeful mood in the fact that they actually did ask me what address to send the chip to. Well, I diligently sent back the address they should send the chip, and then
3 weeks later.
Well, I ended up sending a few more reminder emails, but they never did get back to me. Fortunately, an old high school chum of mine, Alan, saw my plight online and sent me an email saying I can give them a call for you. Now, Al is what you would call a polyglot. He originally hails from Singapore, and when I first met him at school, he spoke English better than I did. In the 2 years that we were in high school together, he managed to learn French and also learn Cantonese from his girlfriend. Now, Al didn't record any of the calls for me, but he did tell me they went something like this. After calling first and conversing in somewhat broken English with the other side, he established that they could speak Mandarin, so he started speaking Mandarin. He then was transferred to another person after discovering the nature of the call, who immediately broke out in Cantonese. So Al broke out into Cantonese. So after a few minutes conversing in Cantonese, Al was transferred to somebody else, who started speaking Wu, which is the dialect spoken in Shanghai. Now Al picked that language up as well when he was working over there for a few years, and tried to converse a few minutes with this fellow, and eventually he hung up and he couldn't get back to anybody else. Now, to make a very long story short, it turns out in the end, Al was able to speak to someone in somewhat of authority, and stated that they would not be able to send me any replacement 3021 chips, as they were for the Chinese market only. Perfectly legal to trade within China, and to put in products to send overseas in China, but totally illegal to send out of China. Now, Al told me this was sort of normal for many Chinese chip manufacturers to make clones of Western chips and sell them only on the domestic market, as they would break their relationships with the large chip manufacturers of the world. So I thanked Al a lot for his help, and then was right back to square one again, a dead 3021 chip. So I immediately started Googling for a 3021 chip. Now, I never did find one, and the only reference I ever found to it was one on the TI help system, where someone was asking for the same advice on finding this chip, and they said it's not one of ours. So now where to start? So let's go back to the circuit and block diagram I came up with in my earlier videos. Now we know from these two diagrams that the only purpose of the two output op-amps are to boost the small signal coming out of the magic box up to 6 volts in the case of the AD8009 op-amp, and up to 24 volts in the case of the 3021 op-amp. So all I really have to do is find an op-amp that's got the same properties as the AD8009, but can take a much higher voltage. So with just a quick look at the AD8009 datasheet, we know that we need a very high slew rate of 5005, a good rise time, large horizontal bandwidth, a large small signal bandwidth. So looking at my notes I made before, I know the supply operation for this particular op-amp will have to be over 13 volts. So that gives me a 30 volt operating range. Fortunately, 99.9% of all op-amps that share the same footprint also share the same input and output pins, so no worries there. Now, finding a replacement could be tricky. In the old days, you had to go through scores and scores of differing data sheets and compatibility books to figure out which one you wanted. Nowadays, all I had to do was go to Texas Instruments, where they have a nice tool where you just put in the chip that you're looking for a replacement for, and it'll tell you the Texas Instrument part that you want. Then all I really had to do was look around to see if there was a higher voltage and dual op-amp version of the same chip that I was looking for. Now my search did come up with two op-amps, the 6703, which was a drop-in replacement, and that one doesn't come in a dual op-amp package or with the proper voltage I need. The other one, the 4303, did have a dual version and the voltage range I required, but it doesn't have the right footprint to match my circuit board. So those two op-amps are off the table. Fortunately, Texas Instruments also has a lookup application, where all I had to do was put in the parameters I'm looking for, and then hit enter, and I get a whole list of the different operational amplifiers that might work. Eventually, searching through all the different lists, I found that the THS FeelElec 3092 was my best bet, as it had the right voltage range and had the right package size. Reading through the datasheet of the 3092, I discovered that one of its applications was for arbitrary waveform generators. I also found on the datasheet this typical use, the circuit diagram. And if you notice here where you have this resistor, inductor, and capacitor network, it's basically the same one as found on the board. So my confidence level is going up a little bit with this chip. So I ordered a few up. I also ordered a few other ones in the same sort of product range, so I'd have a couple ones to work with in case this one really didn't work. And then...
So much later that the old narrator got tired of waiting and they had to hire a new one.
Over the past few days, not one, not two, but 3 boxes of chips came in today. Or different days over the past month. Ordered them over various times. This one in September, this one October, and this one in October as well. And now it's middle of June, so what? There is our chip shortage in action. Hence that intro.
So back down to the lab I go, and I'm not going to bore you with the full chip removal and replacement part. So let's just skip right into what happened after I did the swap.
Here we are, back on the bench, semi put together. Okay, got it far away from the power source there. Let's put it this way. There, that's better. Don't want to touch anything in there with my wires, as that's full mains voltage going through. Okay, alright, got 2 probes. I'll take my channel 1 probe, which is bluey. All nicely compensated. Take that off of there. Stick that on here. And put that on channel 1. With the B and C connector, turn channel 2 off. Off for now. No signal on channel 1, so we'll turn her on and see if we get any magic smoke. Well, no magic smoke, which is always good. And a peep. Ah! We're getting a signal. There we go. Auto scale. Continue. And that's supposed to be 1 kilohertz at 6 volts. Whoa, look at that.
And there was much rejoicing.
And now, of course I didn't get a pen. We can go through this lovely test sheet, if you remember that one from the last time. Ta-da! Go through all the voltages. And test on the channel 1. So,
Much later.
okay, now that I've got the final test all passed, I can put that away. Or at least I know it's putting out signal across the system. Have to come to the next one. Now I know that I've swapped out once or twice some ICs, and I know I've swapped out, replaced one IC and 2 ICs, and swapped and replaced at least 2 resistors, maybe 3 resistors. So what this thing needs now is calibration. Now, of course, there's no notes or anything how to do that in the docs. Fortunately, with this hobby, the great thing is that we stand on the shoulders of giants. Now, Robert Smorgasbord actually did a calibration on the 2-channel job. And basically, from what I can tell, the 3-channel job is just a little different. As you can see, let me just turn this off now. I don't want to zap everything. There's 1 2-pot, 1 2-pot, 1 2-pot, plus 3 pots over there. It might be different on this one. Let me zoom in a bit. We'll see. So there's 6 pots, of course, 3 for each channel. 1 2 3, 1 2 3, 1 2 3. So I'm taking that. These 2 go with this channel, these 2 go with that channel, these 2 go with that channel, and actually they're marked down here which of these are these channels. Fortunately, Robert did give out very detailed instructions how to do it. I'll go through at least one channel on that basically one of these pots does the symmetry of the signal, the other pot does the amplitude, and then most likely this pot down here does the DC offset. So I made up another nice sheet of actually how to do it. That's my instruction sheet. Oop, too close. Zoom out. The instruction sheet. Right. All I got to figure out is what does P12, P12, P13 do. So I'll turn it back on. And a way to tell is, according to the setup sheet, we'll set it at 10 kilohertz, 10 volts, auto scale. Let's see over here. I think we can see all that. Continue. Pen over here. Alright, so I mark this 1, 1. What does that one do? Alright, so that is amplitude. Moving both. Amplitude. P2 is going to be symmetry. I bet you. Dollars. Credits to Navy Beans. Nope, that's amplitude. So this must be symmetry. Oh, it does it both. Oh, how about that? It does both of them. Ah, interesting. So they both do amplitude. Anyway, channel 1 is here. I think that's DC offset. It looks like it anyway. Doesn't like that. Anyway, so that must be DF offset. So let's go. First thing we want to do is put our signal generator and probes all set up. 10x, 10x, amplitude 10 volt, 0 volts. Waveform, we want to do the DC first, voltage at 0 volts, and that's pretty close there. So my coupling is, I bet I got it on, nope, got an AC coupling, it's supposed to be on DC coupling, there we go. Move that down, I think, yeah, that's definitely, there, just covering that line. So that one's done. So then we convert over to a square wave, 10 kilohertz, amplitude 10 volts. We'll set the bottom. No, that one's doing the top. Okay, you can see there that's doing the top only. So the top one must be symmetry. Ah. Yeah. So we do the bottom one first. That would be P2. We'll set that to 5 volts. Five, 9, 3, nope, that's 6. Oh, way out. There. No, 6, 7. 5 volts. And then we'll do the symmetry. We want the top value just down a little. Five and 5. How about that? Got it spot on. Alright, that's basically how you do the calibration. I'm just going to do the rest for the other 3 channels. No need to watch all of that. It's the same over and over again. But please do go to Bob's channel Robert's channel. It's a good one. I'll leave a link in the description down below.
So after calibration, I decided to do a little more testing, this time checking the maximum output voltage with the maximum frequency. And unfortunately on channel 1, I got this.
I get jitter. I don't know if the camera can pick that up at all. That's at 24 volts. It's 5, see, get a little clipping there too. 24, 23, 24 volts, and then I start to get a little clipping. I put it up to 6 megahertz, and then start changing. Yeah, see, 6 megahertz and amplitude of 24. I start getting it. 7 megahertz, I get it. 8, 9, 10, 11, 12. So I have no idea what's causing that. Oh well, back to square one again. So I was looking at my jitter. There's 14 volts at 10 megahertz. Go up to 24 volts, there's my jitter. But I did finally found a solution. And there it is. And you want to see what the solution is? I'll go over to the board and show you. Come on, move over there. It's the heatsink. Put the heatsink in, the op amp works fine. Take the heatsink off, it'll start to heat up again, and it'll back into jitter. Forward camera. I get the head to work properly on this thing. So put the heatsink back in, jitter goes away. Take the heatsink off, and there's the jitter. So you know what? It's all set to be put back together, and that's what I'm going to do now.
So that's really just a wrap up now. All I have to do is put it back together. The only special thing when putting it back together was that I remembered to leave small leads where the wires for the fan went, so I can put those together. And as I was hooking up those wires, I noticed there was a bit of a blodge on this particular design. Seems they wired it directly to a capacitor and directly to a voltage regulator on the board. So the fan was obviously an add-in before the board was designed, as there are no pads for it on the board. So now just for some final notes, the most important takeaway is that you can actually fix a device that you don't have the schematic for, is made up of SMD components, and whose components have been largely obfuscated. I was lucky in this case, as they did leave the AD8009, which gave me a good hint as to what op amp to use to replace the mysterious 3021 op amp. And of course lots of notes helped, as well as making a mini circuit diagram and a block diagram. So in the end, I think anyone with just a little bit of experience could actually repair this particular
There we go. All back to semi-normal. Now ready to put it back on the bench. Yay! That was a long one. What, a year? Almost 2 years to get the damn thing fixed. Oh well. On to something new. Riley, are you going to help me with my next project? Transistors, Riley? Riley? Nothing? Nothing, I guess. We can play with transistors, Riley. Nah.
Not today.
Not tonight.